Hello InfoPerson, this is Anton, and today we're going to discuss one of the biggest mysteries in science of all time. The mystery being, how exactly did the life on Earth begin? Or to be more specific, what factors potentially played the biggest role in its formation? And can we actually find similar factors somewhere else out there in some other star system? And though for a very long time scientists have had bits and pieces of this particular puzzle, there was never really this one answer that essentially explains everything at once. But for the most part, we know that life requires energy, it requires water, and very specific chemical elements. But recently, several major studies you can find in the description have now completely reshaped our previous understanding of some of the earliest days on planet Earth, and thus presented us with a slightly different explanation for how scientists now think life potentially began. And specifically very extreme conditions, including an ancient lava world, a very exotic type of rain, and of course an enormous moon, creating some very powerful gravitational effects that essentially created this natural chemistry lab, which resulted in the formation of first life molecules. And so based on these studies, let's discuss some of the evidence and some of the discoveries, and possibly discuss potential conclusions. And so I guess let's start with these first 500 million years in the existence of our planet. Now previously, scientists actually thought that Earth potentially cooled down pretty quickly, with the oceans forming relatively quick as well, within approximately 100 million years, with simple organic compounds inside the oceans spontaneously assembling into self-replicating molecules and eventually becoming enclosed within membranes to form simple cells. But though this was a cool proposition, there was not enough evidence. And so instead, over the last few years, researchers actually tried to recreate and simulate some of these conditions in order to find out if any of this makes sense, and thus discover what really happened and how it all began. And while we know for a fact that approximately 4.6 billion years ago, Earth formed as a very chaotic molten volcanic planet that was heavily bombarded by meteorites and comets. But then, within just a few million years, so once again about 4.5 billion years ago, a Mars-sized object, referred to as Theia, collided with the planet, reshaping it dramatically, and at the same time forming the Moon. And while this powerful impact first of all left Earth as a global magma world, or basically a lava planet, and also created this massive object orbiting very close to it, with a single orbit only taking a few hours. And that's because back then the Moon was actually extremely close. And while one of the main discoveries from this recent study is that it's extremely likely that Earth did not cool down fast, and very likely stayed hot much longer. And there were two main reasons for this. First, it was our giant moon. Because it was so large compared to the planet, and because it was so close, it actually produced enormous gravity effects, or specifically tidal effects, which created a kind of a kneading effect on the entire surface of the planet. In other words, the Earth's interior was kind of kneaded, very similar to a dough, creating these massive amounts of tidal heating, preventing the planet from cooling down. And at the same time, because of this collision, and because of all of the magma on the surface, this also generated an enormous steam atmosphere, very likely creating a thick greenhouse atmosphere blanket that trapped all of the heat and maintained relatively high temperatures on the surface, which actually created something referred to as global radiative equilibrium. A sort of a state where the heat coming from the moon's gravity and the greenhouse effect from the atmosphere balanced out with the heat escaping into outer space. And according to the study, this period could have lasted for hundreds of millions of years, which turns out might have been necessary for all of this life-needed material to actually form. And so here the authors demonstrate that the tidal heating and the greenhouse effect were strong enough to maintain extremely hot conditions on the surface. And though I guess you would think that because of this would make the world basically uninhabitable, in reality this type of a lava world creates very specific chemistry that's essential for the formation of life. And so in a separate study, researchers also found out that this type of an atmosphere, enriched in certain gases that are basically lacking today, and of course involving these very hot conditions, was essentially kind of like an oven. It cooked certain elements, creating the stage for the future Earth that would have these perfect molecules that could then assemble into something more complex. And specifically here, with the atmosphere enriched in methane and carbon dioxide, researchers found that the ratio of these elements was actually perfect in order to generate prebiotic components. For example, the methane to carbon dioxide ratio was approximately 0.1. And that turns out to be a perfect number, or basically creates a kind of a perfect setting for photochemical production of hydrogen cyanide. And though hydrogen cyanide is obviously toxic to humans, it is absolutely crucial for the origin of life and represents one of the most critical building blocks inside RNA and various proteins. And so these studies essentially suggest that the moon's gravity and these initial greenhouse conditions essentially cooked the Earth's atmosphere for hundreds of millions of years, creating a surplus of these life-crucial chemicals all over the surface of the planet even before it solidified. And so when the planet cooled down enough and when water started to appear, the mixture of these chemicals with water started to actually create some of the first amino acids. But at the same time, this was not the only source of all of these chemicals. A lot of the stuff also came from outer space. And so while Earth was cooking its own chemicals, it was also constantly getting deliveries from various meteorites and comets. And some of the recent observations from telescopes like ALMA definitively confirm that complex organic molecules are definitively present in a lot of the space dust, and specifically a lot of disks of newly forming stars. So basically the dust that eventually forms planets. With official confirmations of ethylene glycol and glycolinitrile, the precursors for various amino acids, officially confirmed inside the disk of a star V883 Orionis, a star that kind of resembles the solar system 4.5 billion years ago. And here there's even evidence that the cosmic dust sort of acts as a catalyst, helping simple molecules like carbon dioxide and ammonia combine into something more complex, even in freezing conditions of outer space. Which means that by the time all of this arrives to the planet, it will be essentially delivering much more complex chemicals, able to mix and create relatively complex organic molecules, with experiments even showing that simple amino acids like glycine can spontaneously form even on the surface of dust grains in the middle of space. And especially bringing things that the early Earth potentially did not contain. For example, enriched amounts of phosphorus and sulfur extremely likely came from outer space, and as we know today, are absolutely vital for life. And so a lot of the cosmic dust from the rest of the solar system very likely brought these elements for millions of years and cooked them along with everything else. And so once this very hot Earth was enriched with all of this stuff, and once it started to cool down, which very likely happened approximately 4 billion years ago, it finally started to form liquid oceans, enriched in many of these elements that apparently did not need much time to suddenly create life. As a matter of fact, it only took maybe 100 to 200 million years for all of this unusual soup to actually form some of the first cells, with some of the earliest evidence suggesting that life already existed 3.8 billion years ago. But there were still certain unanswered questions, because we know that life still requires some other elements that are usually kind of difficult to access or might have been actually absent from early Earth. And one such element is boron, something that's explored in this study. And that's because boron is necessary to stabilize sugars used by RNA, but we also know that in these early oceans, boron levels were extremely high and very likely toxic. And so it was not entirely clear at first how life was able to overcome this particular barrier. But this study now potentially solves this with a mineral referred to as tourmaline, in other words with gemstones, which very likely acted as a kind of a geological sponge, soaking up all of the excess boron and eventually leaving just enough for life to form and to thrive in the oceans. In other words, it was now the geology that was now causing the Earth to change and to reach conditions where life could suddenly start, with pretty much most of the evidence today pointing at basically one source, the hydrothermal vents, also known as black smokers. This is something we usually find on the ocean floor, and based on many different studies we know that various reactions around these vents, especially involving iron and sulfur, can successfully power a lot of metabolic reactions, even sometimes without the presence of the actual cell. In other words, various metabolic processes like the carbon fixation process can actually occur spontaneously, resembling typical cells, even though this is happening on the surface of these hydrothermal vents. With additional studies discovering that the combination of these hydrothermal vents and various types of volcanic glass, specifically formed by volcanic eruptions and even meteorite impacts, seems to have been responsible for actually forming information-storing RNA strands, which scientists were able to recreate by passing nucleotides through volcanic glass. In other words, they were able to form RNA strands by copying the conditions on this early violent Earth through the use of volcanic glass, with a lot of additional experiments essentially recreating a lot of these life-forming reactions, such as for example ATP synthesis, in very similar hydrothermal vent environments and without the use of cells, or obviously without the use of life, essentially indicating that the chemistry of life possibly started in these conditions in the depth of the ocean, inside or on the surface of these vents that were releasing a lot of materials. And so this basically suggests that some of the first protocells consumed the energy directly, which was produced by these inorganic chemical reactions inside the rocks. But the obvious question is, okay, so how did the cells form then? In other words, we have these chemical reactions, but how did all of this end up inside a cell with an actual cytoplasm? And even today this is a bit of a tricky question, because we don't really have any specific geological evidence and don't exactly know how and why cell membranes formed. But the researchers from Newcastle University demonstrated that the fatty acids required to form stable cell membranes might have actually formed spontaneously by combining hydrogen-rich fluids with carbon-rich ocean water inside of the hydrothermal vents, which basically suggests that membranes could have also emerged inside these structures and then somehow enclose some of these chemical reactors, creating some of the first protocells. And by the way, these hydrothermal vents are also thought to exist on a lot of different moons out there, including the famous Enceladus and Europa, implying that something very similar could have happened there as well, and might still be happening even right now. And it all possibly started with these protocells, or these very simple lipid bubbles, that basically started trapping organic molecules and accumulating them inside. Although interestingly, some of the experiments also show that it's actually the freeze-thaw cycle, or basically conditions involving the freezing and the unfreezing of water, that might force these very simple bubbles to slowly grow in size, to fuse, and to eventually become even more complex over time. Which means that at least some of the water on the surface had to freeze in order to start forming some of this complexity. But even though some of these artificial cell systems and even some of these chemical reactions have been successfully recreated in a lab, we still don't really have the full story yet. In other words, we don't really have a complete timeline, and there are still a lot of missing pieces. But based on these early discoveries, we can now also refine some of our search for some kind of an extraterrestrial life somewhere out there. And that's because many of these studies suggest that the unique conditions on the planet Earth were actually mandatory to create these ingredients for life. For example, we had to have a large moon that would basically let the Earth cook for at least a few 100 million years. And at some point, we had to have hydrothermal vents in order to have all of these materials finally assemble. And though it is quite possible that the Jupiter's and Saturn's moons are doing something very similar, we're not going to know for sure until we visit those moons and until we find something there, or potentially find nothing. And though the studies in this case suggest that life is not just some kind of a lucky accident, but is a result of chemical architecture, in this case they also suggest that this architecture has to be very specific and requires a series of lucky events that not all planets out there are going to experience. But because this is still an open-ended mystery, we'll definitely come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining the channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.